So, Mehak,
Yes, sir.
were you able to do the questions?
Yes, sir. I was able to do the questions.
Okay. So let's see. This is you can consider as a small thing by which I will know that you know these topics or not. So series and parallel combination. The circuit is not to be very complex. I'm taking just simple circuits to make your concepts clear. Okay. If you can answer me orally, that's very good. So let's see again a very simple circuit. So you are given a 6 volt battery. Suppose if you have this resistance as 6 ohm, 9 ohm, we have this 3 ohm, and this one as, let's say we have this as 4 ohm and 6 ohm. Not 6, I don't want 6. Let's say 12 ohm. Okay. Now you have to find out, first of all, of course, you have to find out the equivalent resistance. This is, of course, has to be found out. You have to tell me equivalent resistance. Then you have to tell me I have an ammeter here. Let's remove this. Okay, see. So I'm putting an ammeter here, and this is ammeter A1. Here you have another ammeter A2. Here you have another ammeter A3. Here you have the voltmeter V1. Here you have the voltmeter V2. So questions are, you have to find out the readings of ammeter A1, A2, and A3. A1, A2, and A3. And you have to tell which is there any reading which is same. So you also have to tell, is there any pair of ammeters which will show equal reading. And the last one, third one, you have to tell voltage in ammeters, voltage in voltmeters Voltage in the voltmeters V1 and V2. These are the voltage that we have. Then the last one you have to tell the potential difference across across 6 ohm resistor.
That's also
Yeah, that's all you have to tell.
okay.
So I think the first one would have been done by everyone. Amatur Rahman, have you done the first one?
Yes, sir.
Okay, so what is the answer you are getting for this first one?
7.6 ohm.
7.6 ohm. Right. So you are getting your answer as 7.6. So I have wrote down your answer. Then secondly, is there anyone else who has also got any other answer? Srilasya, what's your answer for this? Have you calculated?
No such thing.
Okay, just do it. Don't consider this to be correct. Okay, I have not verified this. And if anyone is finding any issue, K. Subha Charvik, can you show your notebook?
Sir, I came right now. I started it. Like what?
Okay, okay. So just start doing this.
Yeah.
And Rene is there? Rene, are you there? I don't think. Rene is not here. Shravani?
Sir, I have just now joined the class, so I'm doing the sum, sir.
Okay. Okay. So Amatur Rahman has corrected her answer. It's 6.6 ohm. Okay, as you can observe here, I have calculated the equivalent for this first one is 3.6. The equivalent for the second one is 3,
Yes,
and
sir.
you get the total as 6.6. So everyone should check this before proceeding, that you should be getting your equivalent resistance as 6.6 ohm. Okay. So Medha Anthony, did you get the same answer or is there anything else?
Sir?
What is the answer that you have got?
Sir, I have joined late, sir, so I am not at the point.
For this first one?
Sir, I just joined now, so I don't know what is happening.
Okay, so you should ask what is supposed to be done. Okay, so these are the questions which you have to calculate. You have to find out the equivalent resistance. Okay, so I'm just asking. Vedika, what's your answer?
So 6.6.
6.6 ohm, right. This is 6.6 ohm. Okay, then I think everyone has got the same answer. Mehak, did you get the same answer?
Yes, sir, I got the same answer.
Okay. Now say, actually this question I should have put up this later on. Later on means it should be either the fourth or the fifth point. But this I have asked you earlier only. Readings of the ammeter A1, A2, and A3. A1 you can compute right now. Okay. But to calculate A2 and U3, you must calculate first point 3 and 4.
Yes, sir.
Okay. So if anyone has obtained the answer for A1,
Sir, it is 0.9.
Yes, sir. 0.9 ampere.
0.9. So this you are getting 6 divided by 6.6. Okay. That's 10 by 11. And
Sir,
that you
for
get 0.
A2,
Yeah.
can't we do 6 by 18 by 5?
6 by 18 by 5. Yeah, it will give you the same answer.
Yes, sir. Because, sir, in parallel connection, the voltage will be same across the whole thing, right,
Yeah,
sir?
it will give you the same thing.
So, sir, V1 and V2 will also be 6 volts.
No, they are not getting 6 volts. V1 and V2 will not be the 6 volt. The resultant of this, see, the resultant of this and the resultant of this, they are not in parallel, they are in series.
Ah, right, sir. Yes, sir.
Okay, so suppose I obtain some resultant value for this work, this combination. Let's say I obtain some resultant value over here as R1. I obtain some resultant value over here as R2. So these two, R1 and R2, they are connected in series to each other, where R1 and R2, they represent the equivalent resistance. Okay, so the
Yes.
voltages V1 and V2, they will not remain the same.
Sir, in that case, A2 and A3 will remain the same, right?
So will they remain the same or not? That's what we will discuss right now. So will they remain same or different?
They'll remain the same.
They will remain the same. Let's see. Now I will
Sir,
explain this.
sir,
Yes.
sir, after the combination of 6 and 9 and 4 and 12, we get series connection, right, sir? So over
Yeah,
there,
that
value of current will be same, right, sir?
the value of current in this complete, whatever the total current is flowing over here, that total current will flow through this total.
Huh, yes, sir, right, sir. That's what
Okay.
I was.
But will the distribution remain the same?
No.
See, suppose, okay, here we calculated the value of A1, right? The value of A1 we got as uh, we got as 10 by 11, right? We got 10 by 11 ampere as A1.
Yes, sir.
Okay. So now when this current is reaching over here at this point, so at this junction, it is getting divided into two parts.
Yes, sir.
Okay.
Yes, sir.
So some current I1 is passing through this 6 ohm and some current I2 is passing through this 9 ohm. So will both the currents be the same or different?
They will be different, right, sir? But
They
then when
will
we
be
find the
different.
equivalent resistance of that will be same as that, right, sir?
Yeah. So here both the emitters A2 and A3. For your A2 will show a different reading, or it will be a different current which is flowing through 6 ohm than 9 ohm. Right? But the total of it will remain 10 by 11.
Right, sir. That way we can find the value of V1, right, sir?
Yeah, that way we can find the value of V1. Equivalent resistance we know. Equivalent resistance R1 is 3.6. Equivalent current we know that 10 by 11 is the total current which is flowing. So in that way we can compute the value of V1. Okay. Everyone just pay attention. These are very serious questions just to clear all your concepts regarding this. All your concepts with the circuits will be cleared. Where to apply the Ohm's law. In whatever circuit you are applying the Ohm's law, just observe those points. Okay. Suppose I am applying between these 2 points. Okay. So between these 2 points, what is the total current? Between these 2 points, my total current is 10 by 11. Between these 2 points, what is my total resistance? My total resistance is 3.6. Between these 2 points, what is the total voltage? So that total voltage is V1 and that is not the voltage of the battery. Okay. As this resistance and this resistance, they are connected in series. These two equivalents, they are connected in series. Therefore, V1 and V2, they will not be equal to 6 volt, but I can say that V1 plus V2 should be equal to 6 volt. This should be equal to 6. Manan, have you understood?
Yes, sir.
Okay, so don't say that in parallel voltage is same. In parallel voltage remains same. It means that even if this voltmeter is connected across the 9 ohm, okay, if I ask you what is the voltage across the 6 ohm, so it will be the same. Okay, if I apply some other voltmeter over here at the ends of the 6 ohm, it will show the same reading as V1. I hope everyone is getting my point.
Yes, sir.
Okay, so suppose I calculate here value of V1. So for V1, I should know the total current which is flowing through this, and total current is 10 by 11. Then I know the total voltage is 3.6. So I put here 3.6. Okay. So it will be 36 by 11 volt is what V1 will measure. Okay. Similarly, I can compute the value of V2, and V2 will be equal to the equivalent resistance multiplied by the equivalent current, and equivalent resistance is 3. Equivalent current is 10 by 11. So 10 by 11 multiply 3, it will be 30 by 11. Okay. And if you add these two, see you are getting 6 volt. By adding V1 and V2, are you getting 6 volt or not?
Yes, sir.
Okay. If you make 36 by 11 plus 30 by 11, you are getting 6 volt. So that is correct. Okay. Now see my last question here. If you want to measure the potential difference across the 6 ohm. Okay. So who will answer this question now? The potential difference across the 6 ohm resistor. If the person asks answers, so I will be confirmed that yes, you know the concept. What will be the potential difference across the 6 ohm resistor? Kesuva Charvik, what is the potential difference across the 6 ohm resistor? Yeah, Amatur Rahman,
Sir, 36 by 11.
36 by 11. Okay. It's because that 6 ohm is connected in parallel to the 9 ohm, and hence both of them will remain the same. The potential across 6 ohm will be the same as the potential across the 9. Okay. So whatever was from my point of view, I wanted to make clear. I have made all things clear. We have calculated V1, we have calculated V2, and now you can compute the value of A2 and A3. Okay. To calculate A2, you need to use the value of V1. To calculate A3, you need to use the value of V2. Okay. Now let's see. These are a few practice questions. Do it quickly. We move on to the next problem. Okay. Now I will not explain this. I will explain this only at the end. I will be checking everyone's notebook if you are able to do them as quick as possible. So if you do it, let's see. These are very simple ones. Very simple. Slowly we reach the bar. Okay. So first of all, obviously you have in all these circuits, you have to find out equivalent resistance. You have to find a total current drawn from the battery. Total current drawn from battery. You have to find current through each resistor. This is for all the questions. You can note down these 4 questions which I want from them. Current through each resistor. And I want you to measure potential difference across each resistor. Potential difference across each resistor. Okay, so this is the first circuit. Okay. Again, the same questions. Okay. So if you are getting your answers, tell me the answers. I'll keep a note of all of you. Okay. Here I'm making a column just to note down your answers. Okay.
Third,
Yes.
so for the third one, current through each resistor, will the potential difference be same for both of
If it is same, you give me the same answer.
the
Okay. If it is same, you give me the same answer. That yes, it is same. Okay. I'm not going to give anyone any hint. So this is your first, second question, third question. And fourth. Whatever answer you give, I will note down here and then I will be checking it finally, if it is correct or not. So whoever answers first, I'll write down name over here and write down his all answers. Amatu Rahman has given 2 answers. 3 answers here. So this is for the first circuit. So Shashi has also given the correct answer. Amatu Rahman also, all the answers are correct. Medhansini has given just 1 answer. Mehak. So shall I note down the answers over here in front of you? I think I shall note down. Rene. Yes. Rene and Mehak. You have got 2 things as incorrect. Pravani. 6 ohm, 1 ampere. So Rene and Mehak, just see here, and all others can continue solving. I don't have any answer from other people. Shravani has given answer for first one, third one. Okay. Rene and Mehak, and if anything, anyway, Manan, you have also not given any answer.
I'm giving someone's and I'm typing.
Okay. Okay, see, if anyone else is there who has not understood, see here, I'm trying to explain it once more what happens in the circuit. If this battery is applying 6 volt of potential, so this 6 volt is applied to the complete circuit. It is between these 2 points. So either you find it across the battery or you find it across the complete circuit. It is the same as 6 volt. Now, suppose some current I is drawn from the battery. So that current when comes over here at this point, by the conservation of charges. Conservation of charges means charges cannot be created or destroyed. So whatever charges are flowing through the circuit, they pass through this 4 ohm resistance. All the charges pass through the 4 ohm resistance. They cannot pass through the voltmeter. Okay, as the voltmeter has an infinite resistance, it has a very high resistance. So a very small amount of current passes through V1. So here the path for the flow of charges is just one. They can pass through the 4 ohm resistance, right? So therefore, whatever current is drawn from the battery, that will be the current that is flowing through this 4 ohm resistance. Okay, and since suppose understand it this way, Rene, are you there?
Yes, sir.
Okay, so Rene and Mehak, you need to pay attention. Suppose here 10 electrons are drawn from the battery per second. Okay, so at this point, how many electrons will flow through this 4 ohm resistance? Will it be 10 electrons, or will it be less than that, or will it be greater than that? Rene?
So will it be less than that?
So where will the remaining charges go? Suppose if there are 10 electrons, and suppose only 8 electrons pass through the 4 ohm resistance. So where have the 2 electrons gone?
So it goes to the next.
So, okay, you say that 2 electrons go to the next. Okay, I suppose 2 electrons go to the next. Okay, so all of them have been destroyed now. So how many will reach here back at the battery?
0.
0. So that is the incorrect thing. By the conservation of charges, if 10 electrons are leaving out from the positive terminal of the battery or in any way, so they must complete the circuit. The 10 electrons, if they are moving from the negative terminal, so the 10 electrons will also reach the positive terminal. This is what is meant by the conservation of charge. Okay. Charges will not get destroyed anywhere, or they will not get created anywhere. Okay, so if 10 electrons are leaving from the battery, so all the 10 electrons, they will pass through this resistance. They cannot be absorbed somewhere. Okay, assume some electrons are traveling through the wire. Okay, there is no other way. So they will not be absorbed. They will keep traveling through this 4 ohm resistance. Okay, so there will be 10 electrons which will be traveling through the 4 ohm resistance, and also the same electrons, they will travel through the 2 ohm resistance, and at this point they will also travel towards the battery. Okay, so hence the number of electrons will remain the same. In the series circuit, by the conservation of the charges, the number of electrons will remain the same, and hence the current will also remain the same. Okay, so I hope Rene and Mahek, both of you have understood that in the series combination, it remains the same. The current remains the same.
Yes, sir. Sir, I didn't get where I went wrong, sir. Still.
What happened? Where you went wrong?
Yes, sir.
Your simple thing. Okay, what is the total current that you have got?
Sir, I got 1 ampere.
1 ampere, right? So if you get here 1 ampere of the current which is drawn from the battery, so 1 ampere of the current will pass through the 4 ohm resistance. There is no other path for this 1 ampere current to flow through. As current means flow of charges, it means the electrons are moving. Okay, so it means 1 coulomb of charge is flowing through this wire, and if that 1 coulomb of charge is flowing through this wire from the positive end, so the same current, it should return back to the negative end also. Okay, so without any calculation, understand, without any calculation, you can directly tell that in this circuit the current will be 1 ampere. 1 ampere current will pass through the 4 ohm resistance, and 1 ampere current will pass through the 2 ohm resistance. Okay, the current will remain the same. The current will not change. As in the series circuit, the current remains same.
Yes, sir. Got it.
Got it?
Yes, sir.
So from now onwards, you should not make such silly mistakes. This is what we mean by small things that we are here to correct. Rene,
Yes, sir.
you have also understood?
Yes, sir.
So without any calculation, you can tell that yes, here 1 ampere current will flow, here also 1 ampere current will. I haven't received any answers from Sri Lasya. No answers have been received from uh, there are many people who have not answered. Medha Ansini, have you answered?
No, sir, not yet.
No yet. So why? Have you not understood the first problem or the second problem?
Third one, sir.
Third one.
Second one is done, sir, but third one I didn't.
Third question or third diagram? This third question from the first one.
Yes, sir.
Current through each resistor.
Yes.
So now you have understood, or shall I explain it again?
Can you explain it again? I didn't understand.
Okay. K. Subha Charvik,
Yes.
have you understood this?
Yeah, third one I have you not said, sir. That's what I'm saying.
Okay, third one. Current through each resistor. Okay, third one for this first, right?
Yes.
See. Again drawing the diagram. And Stacy, have you done all? Stacy?
So, Vex, can you go to the previous page?
Yeah, this one.
Yeah, excuse me, sir, for the second question, current through
Yeah.
each resistor, meaning we have to find A1, A2, and A3.
Uh,
Audible, sir?
in the second circuit for the third part, current through each resistor, that means A1, A2, and A3.
Okay, sir.
Okay.
You can change it.
Okay. See. So see, this was the first question. A very simple concept. If
Sir,
I'm
you
applying,
called me, sir. My mic was not working, sir.
so have you done all the questions?
Yes, sir, yes, sir.
So did you send the answer for the second one?
I did not send the answer, sir. 1 minute, I'll send, sir.
Okay. So send the answer. And to those who are able to solve, I will give you some other questions. I will add up more questions over here. Okay, so that till then I can explain other people. Those who have not understood, I'll keep them explaining and I'll give you some more questions. Okay, just to clarify your doubts. Okay, and once we'll reach to your doubts also.
So here potential difference is already given, so why need to find
In this one,
6? Yes, sir, 6 volts.
okay, see. Why we need to find that? So this is the 6-volt battery.
Yes.
Okay, the battery is giving us 6 volt. So you can assume this means actually the voltage, it means what is the amount of force by which the electrons are pushed in the wire. Okay, so you can assume it, give it just a feeling of what is happening. The wire here is having a number of electrons. Wire is full of electrons. There are a number of electrons and they are lying just in line with each other. All the electrons, they are lying in line with each other. So wire is completely full of electrons, right? Now the negative terminal of the battery, it is trying to push these electrons. Okay. And by the potential of battery, when I say that the potential of the battery is 6 volt, so it means that how much of force the battery is applying on these electrons. If you use a battery of high volt, suppose I use a battery of 12 volt, Okay, so a battery of 12 volt will apply
Sir?
more amount of force. Yes.
Sir, I was disconnected due to a glitch. I was wondering if you called my name by any chance to check in.
No, I thought I just saw that someone left, but I didn't call, I think.
Okay, sir.
Okay. So if you have done these questions, so there are two people who had got some error. So one person was not able to get. So I'm explaining that. Try doing the second one.
Yes,
Okay.
sir.
And if you want, I will tell you the answers for this one also, for the second one. Just wait
Yes,
for a
sir.
minute. If you are able to solve, well and good. I'll tell all the answers. A1, A2, A3, V1, V2, V3.
Okay, sir.
So if you are not understood, just say. So by the voltage of the battery VB, what is the amount of force? The battery is pushing these electrons. So hence the electrons will move from here. All the electrons are moving like this. Okay. So suppose if 10 electrons are moving from here. So 10 electrons will cross the 2 ampere, right? And the same 10 electrons will cross the 4 ampere also. Okay, Rene and Mehak. And there was someone else also.
Yes, sir.
Okay. So you got this?
Yes, sir.
Medha Ansini.
Yes, sir.
Okay, so if 10 electrons are moving from here, from the battery, if the battery is pushing out 10 electrons, so battery is providing 10 electrons from here. So the 10 electrons from here will move in the ahead. 10 electrons will also move from here. Okay, hence the current will remain the same. That is what we mean by the series combination. So in the series combination, current remains the same. Okay, so both 4 ohm and 2 ohm, they have the same current which is drawn from the battery. So if the battery is giving me 1 ampere of current, as I calculated here, my total resistance is coming out to be 6 ohm. Okay.
Yes, sir.
My total battery voltage is coming out to be 6 volt. So what is the current that I am doing? So current I am getting is V by
One.
R, that
Yeah.
is 6 by 6, which is 1
1
ampere.
ampere.
So I get the current as 1 ampere. Okay. So total current that battery is giving is 1 ampere. So 1 ampere current will pass through the 4 ohm and 1 ampere current will also pass through the 2 ohm resistance. The
Yeah.
current will not get lost. Okay. So
So
you can
answer
follow
is 1 ampere.
yeah, so you can follow some of the analogy. You can either consider it something like this. Suppose this is a pipe, this wire is a pipe, and through this pipe, water is moving. So whatever amount of water moves from the positive terminal, the same amount of water will flow through the 4 ohm and the same amount of water will flow through the 2 ohm. Will the quantity of water change or will it remain the same? Yeah, Medha Antony,
It
the
remains
amount,
same.
it will remain the same. So that is what is happening with the current also.
Okay.
Okay. Now suppose if I make a branch like this, suppose I create a branch. So what will happen? Now the water will get distributed in both the branches. Some amount of water will go in this branch, some amount of water will go in this branch. Okay. So that will what happen with the current if the resistances are connected in parallel like this. So the currents will get distributed and it will not remain the same. Okay. In that case, suppose some current I1 is flowing in this resistance, some current I2 is flowing through this resistance. So the total current I will be equal to I1 plus I2 in this case. But in this case, the current will remain the same. As whatever amount of water is moving from here, the same will move through each of them. Okay, understood this?
Yes, sir.
Okay. Now the other thing is that the voltage in the series circuit, when both of them are connected in series, so the voltage becomes different. Voltage, there is a voltage drop that occurs. Voltage drop means this resistance is making there is some work done by this current in crossing this resistance, and hence there will be a decrease in the potential of the current. The potential will decrease. Okay. And it requires some effort by the electrons to cross this resistance. They cannot cross it easily. So therefore some amount of work is done, and hence there is a voltage drop. So out of, you can assume it like this, that out of the 6 volt, some of the voltage will be utilized by this 4 volt, 4 ohm, and some of it will be utilized by this 2 ohm. And hence in this, you will say that V1 plus V2 will be equal to 6 volt. Okay. Now, to apply the Ohm's law, you can apply in any part of the circuit. Suppose I apply the Ohm's law just in this part of the circuit. Let's say the circuit is A, B, C, D. So I am applying the Ohm's law in the circuit A, B, C, D portion. So in this portion, what is the voltage? That's V1. What is the current that is flowing through this 4 ohm resistance?
1.
1. And what is the resistance itself?
4 ohm.
4 ohm. So what will be the voltage V1? I can use V1 is equal to I times of R1. I is 1, R1 is 4. So I get 4 volt. Okay. Similarly, in the second one, now I apply the Ohm's law in this part of the circuit. So in this part of the circuit, what is the current flowing through the 2 ohm resistor?
1.
1. And what is the resistance? 2.
2 ohm.
So V2 will be equal to I into R2. Okay. And it will be 1 into 2 and hence 2 volt. Right. So 4 plus 2 will give you 6 volt resistance. 6 volt. Okay now?
Yes, sir.
Okay. So this is what everyone should be clear. Shreyasi sent the answer. Okay. Now see. So for the same thing, if I connect them like this, so both of you will do this one. Medha and Mehak and Rene, you do this thing. Now, if I connect them in the parallel combination, the same one, I have connected 4 ohm, 2 ohm in the parallel combination, connected them to the 6 volt of the battery. Okay. And again the same questions. I want the current I want the current I1, I want the current I2, I want the voltage across the 4 ohm resistance. I also want the voltage across the 2 ohm resistance. If it is same, so you will say this is same and this value is this. If it's not same, so you will say no, this is not same. Okay. So all of you note down this question. Just those who had not understood this. Medha, Ansinish, Rene and Mehak. Kesubha Charvik, you also did not give the answer.
Sir.
You didn't give the answer. So if you have not understood, just you should tell me that no, I have not understood. Have you understood?
Yeah, sir.
Okay. So solve this question. All of you solve this question.
Sir?
Yes.
Sir, on the previous page, the second question, sir. I'm not understanding how to find A1 and A2, sir. A3, I got it, sir.
So E3 you got. Now see, where is the current distribution taking place?
At that right left corner, sir.
Okay. So let's mark these points. I say as P and Q. Okay. The current distribution is taking place at P and Q. All those people whom I explained the first question, they did not understood. So they should do this problem. They should do this one, the parallel one, which I have given. Okay. So they should solve this parallel one. To the other people, I am explaining the second problem. Okay. Okay, see. So, Shreyashi, I suppose some current I is flowing over here, and that I is getting divided into two parts. Some part I1 flows through the upper part of the circuit, and some part of flows I2 through the lower part of the circuit. Okay.
Yes, sir.
So now at this point, I1 flows through 500 ohm. I1 flows through this 500 ohm, and it comes to Q. I2 flows through this 2000 ohm, comes to Q, and again gets collected,
And it
forms
becomes
I.
I.
Okay. So, so can I say that the upper part and the lower part, they are in the parallel combination,
Yes, sir, yes.
and they are connected to a common potential?
Yes, sir.
Okay. So the potential to the upper part is 3 volt, and potential to the lower part is also 3 volt.
Yes.
Okay. So now can I calculate the currents, A1 and A2?
So, sir, here V1 will be 3 only, sir.
Yeah, V1 will be 3.
Yes,
That's
sir.
just
And then,
to
in
confirm.
the upper part, sir, V2 plus V3 will be 3.
Yeah, V2 plus V3 will be equal to 3.
Understood. Yes.
Okay. So let me give you the answers, whatever answers you might be guessing out here. So these are the answers for the second one. For the second one, you have equivalent resistance R equal to 1000 times 2000 divided by 3000. This will be 2000 by 3. Okay. So are you getting this equivalent answer? Equivalent resistance?
Yes, sir.
Yes, sir.
Then the total current I will be equal to V by R, which is 3 divided by 200 by 3.
2000.
2000, yeah. So total current I will be equal to 3 divided by 2000 by 3. So we can multiply 3 by 2000. And this will be 9 by 2000. Okay. So you can write it as 9 by 2 milliampere, which will be equal to 4.5 milliampere. Okay. So is there anyone who has got this answer or anything different?
I got it in terms of ampere only, sir.
Okay.
0.0045.
So try to convert it. If you are getting too many zeros, so convert it to milli or micro.
Okay, sir.
Okay. So Amatur Rahman, did you get the same answer or different one?
Same only, sir. I sent you for second answer.
Okay. Just let me see. Okay, so first one you got this, you got 0.0044. Okay. So that's 4.5. 9 by 2, it's 4 by 5. Okay. Now let's see the other parts.
So can you tell the parallel one? I sent the answer.
For this parallel one, which answer? First,
Yes.
second, or third?
So can you tell all so I can correct it? I already sent you the answer.
Yeah, so the correct one is here. The equivalent resistance is 2000 by 3. That is 666.67 you might be getting.
I'm telling about the first one.
This first one.
First one parallel you gave, no, sir. So that,
Okay, this one.
yes,
Right, this one.
yes.
Okay. So here you have your equivalent resistance R will be given by 8/6 or 4/3. Is this what you are getting?